Okay, so we're going to start. This is lesson 15 here, dealing with velocity. Um, Again, this is through an 1819 version. Some of the tabs might be a little different. I want you to pay more attention to my code as it deals with velocity, rotation speed. Here is the 1920. You see we're dealing with the same code. So pay more attention to the code that I have on my screen as we go through things. I did a lot of these things and played around with them in a previous version. So rather than going back and copying and pasting and redoing them in the 1920 version, um, I'm just going to revisit the other version. Okay, so we have done all this in a sense, to change the rotation of an object to make it look like it is being animated. It was sprite.rotation equals sprite.rotation plus or minus an integer. Okay, to get it to continuously rotate. And as it goes through the draw loop, as it kind of acts as a for loop and goes through those increments, it will continuously rotate. Same thing with velocity. Okay, if sprite.x equals sprite.x plus or minus 1, that um, the x will increase or decrease continuously, making it appear that the sprite is moving on its own. Same thing with velocity y or sprite.y. So we have done these concepts before. So in essence, okay, if sprite.velocityx equals 1, then underneath that line of code would be sprite.x equals sprite.x plus 1. Okay, so again, we have done all that. Now here, tab 3 on mine will be the same as tab 10 on yours, where it kind of goes through and it explains all this. Okay, with velocity, you see here, hippo x plus 2, okay, where hippo velocity x equals 2. So these right here are in essence the same thing. So you can see, what is working behind that property block. Okay? And then within, here, these things are happening inside the draw loop, while this velocity up here we set to the sprite outside of the draw loop. That doesn't mean that we can't change the velocity within the draw loop. Okay, we can set different parameters, go back and forth, things like that. So I'm going to go through this lesson, move through some things, just so you can see how things work. I will pause for a second, long enough that you can see the code on my screen, see how the code gets those different things to react on the screen. Understand that you can't simply just write the same things down if I have certain uploaded sprites. Okay, if I have uploaded a sprite, you might have to go through and upload it as well, or just change the name of the sprite name in your code to match the sprites that you have. Again, if that doesn't make sense, email me and I can walk you through it. Okay, so here, inside the draw loop, what's going on? Well, I'm drawing my background, but this fish, okay, I have set the velocity outside of the draw loop, and that is continuous. Okay, what we'll get to as we change velocity and things like that in further lessons, the appearance of something speeding up or speeding down as it increases or decreases through the draw loop. But that fish, it's still out here somewhere in La La Land. but the velocity is set to 0.4. You know, if I change that to, let's say 0.9, what is that going to do? It's going to make it go faster. Okay, I could even slow that down to 0.09, let's say, and it will make it run very, 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 very slow. Okay, but you can take a look there, specifically here at the velocity in this and how it affects that fish. Moving on to puzzle 5. Okay, so a lot of different things that are going on here, and I have kind of gone above and beyond you know, what it is asking you to do. And I've done that by setting some parameters rather than go through all of this. You know, I'll just let you kind of look through it and see what's happening, because once my feather gets to a certain Y position, okay, it is resetting. Okay, here, you know, as a feather falls out of the sky, it's not just going to you know, fall straight down. You know that the rotation is going to change. That's what's happening here, okay, where the rotation is changing. Okay, if the rotation equals, you know, it rotates to the right one way, then let's change its rotation to move the other way. If it goes to the left, and that's what this is doing right here. Okay. So what is happening? How is this feather getting down here and resetting to the top of my screen? That's what you'll see right here. When, or you know, if the Y position is greater than 400, which is, remember my canvas is 400 by 400. If the Y is greater than that, then I want you to reset the Y. I want you to set it to -5, so that -5 takes it off of the screen to make it appear that, you know, it is starting over. Okay, and these are my X's. You know what's happening to my velocity. Okay, it's just changing. Okay, and here is, you know, some velocity Y, velocity X. Now my, you know, my velocity X is moving to the left and to the right. My velocity Y is its speed moving downward. Okay, so this has been on here long enough that you can pause and take a look at that code and see how that works. Take it one line at a time. Okay, add different things at a time so you can see how those affect the feather. Don't just copy all this down at once. Okay, moving on to puzzle 6 here, dealing with rotation, continuous rotation of the sun. Okay, the rotation speed equals -25. Okay, this one's pretty easy. Here, sprite rotation equals sprite rotation plus 2. That is what is under the hood of this sun dot rotation speed. Okay, so that's what's happening there. Okay, so this, we're going back to the last lesson 12, I think it was, where we're dealing with keyboard input. So we have our rotation speed now. We're throwing some conditions in there. I don't want my pinwheel to be continuous. So it's saying when or if the space bar is pressed, then I want the pinwheel to spin. Okay, else that means the keyboard or the space bar is not being pressed, then the rotation speed equals 0. Okay, so it is not doing anything. Okay, so you can pause there and take a look at that, but that is adding you know, a keyboard conditional in there. Okay, so this is getting something to rise when the keyboard is hit, but it doesn't stop it. Okay, this is just a regular if statement. There is no else. Okay, on the last one, the rotation stopped. If I wanted this to stop, I would have to add an else in here that, when the key is being pressed, then I want you to make the flybot fly by changing its velocity, else it would be 0, just like it was in the last one. Okay, so once I hit space, this flybot starts flying, but it does not stop, even if I hit space. Okay, it just sets it to -1. A lot of different things you see as we go through all of these different lessons that we're going to end up changing, and we'll have some full control over this velocity. Collisions in lesson 16 gets pretty cool. We'll take a look at. Okay, tab 9. Okay, now kind of like with the feather, now we're setting some in parameters to this fish tank. Okay, this fish isn't just going to keep going off to the left or the right. Once it reaches the end, it's going to turn around. Okay, so we're adding some conditionals. First, we have to set the velocity here to the fish. It's moving to the right when we start. I have fish R and fish L. Okay. So what's happening here, now this looks like it's done for you, but we can still take a look at this text and what is happening. These are fish R and fish L are two different sprites, one fish facing to the left, one fish facing to the right. So when the x is less than 0, what happens? Okay, we want the fish to turn to the right, and the velocity x will be 2. That's increasing to the right. If the fish is greater than 400 out here, as soon as the x value of that fish gets past 400, we're going to make the fish look like it's turning around, fish L, and then the velocity will decrease, meaning that it will move to the left. Okay? Okay, so on this one, I'm saying once that fish gets to the right. Now I've set my animation here. Let me slow this down. Now I've originally set my animation to 2. Okay, it bumps the edge of that tank. It's like, uh-oh, it kind of starts freaking out. Okay, so it changes from 2. If the fish, so as it's moving to the right, if it gets greater than 350, it reaches that edge, it's turning around with the fish L, and its velocity is increasing. Same thing when it gets to the left. Now, what I don't have here, which you should be able to figure out, if the user presses right arrow, the fish swims to the right, and you can do the same thing if you press the left arrow, where you can have control of what happens to that fish. We did that in the last lessons with the ladybug, how when we pushed left or right, those sprites would change. But here are those animations, okay? A fish facing left, a fish facing right. Okay? So once again, there's that code. These are things that you should definitely be able to figure out. Okay, so this is the beginning of my game. A lot more to this, but I am, you can go to the game that I shared and you can look at the code because there's a lot going on here. Okay, and on this one, okay, we're going over jumping. Okay, you now have all the blocks you need to make your sprite jump, but when we are jumping, okay, we have to set kind of this parameter so that when it reaches Let's see, so where is that? Okay, so let's take a look at frog here. Okay, and everything that is happening. So when I am pressing my up arrow, it's setting a parameter. When my frog gets to a certain height, when my frog gets to a certain height, its velocity, in a sense, is going to change. Okay, kind of has gravity in effect, it looks like, so that when I reach a certain height, it's going to go down, but I've also set that bottom parameter. So that the frog stops. Okay, and that looks to be 175. Okay, you can take a look at all of this to kind of see how, it got that frog to be where it is. But you can look through all of this code again on that game link that I shared. It's pretty complex, but as you look through it and you break down the code, you can see what's happening there. Okay, this is the same. This is the game that gets the mushroom to move and be continuous. Okay, when the mushroom, the reason I have -30 is it gives the game player time to kind of reset. The mushroom is going off the screen and it's resetting to the right. Okay. Okay, and then this is just, dealing with looping. Okay. Mushroom is looping. But that's it for velocity. Again, a lot of my stuff on here more complex than yours. That's fine. Pause it. Look at the code. Go back. Look at my game. See everything that is happening there. Slowly apply it to your own. But doing things with velocity, definitely pretty cool within our games. If you have any questions, email me at any time. Good luck.